Okay, let's do some practice calculations with specific heat. So, the equation that we're going to use for specific heat is Q equals Cp times N times delta T. Here's what each of those stands for there. First thing, I'm going to have 480.5 grams of water. I'm going to put that in there, and now I'm going to know that the change in temperature goes from 20 degrees Celsius to 80 degrees Celsius. That's going to be a change in temperature of 60 degrees. That goes here for delta T. The specific heat constant for water is 4.18. That goes in there, and this leaves my unknown as Q. Here's my equation. Now I'm going to be plugging in the numbers there, and the end result, 120,509.4 joules, or 120.51 kilojoules. So that's how much energy is released when that thing is going to cool off. Now, next one here, same idea. I'm going to be looking for specific heat, which is always going to be in joules. So if I have 35.8 kilojoules, that's actually going to work out to be 35,800 joules. That gets plugged in there for Q. My constant for aluminum is going to be 0.897, and the mass is 377 grams. My change in temperature is going to be my unknown, so I'm going to solve for that. Change in temperature is the energy divided by the specific heat times the mass. Solving that out, plugging in my numbers there, my change in temperature is going to be 105.86 degrees Celsius. So I'm adding that temperature, I'm adding that heat to something at 25 degrees Celsius. So I'm going to take that plus 25 is going to give me a final temperature of that aluminum of 130.86 degrees Celsius. All right, now I have a sample of lead. So I'm going to do the same thing right here. I'm looking for how much energy, so that's my unknown. The constant for specific heat for lead is 0.129. My mass is 1.3 kilograms. So that's going to work out to be in grams, 1,300 grams. I put that in there for the mass. The change in temperature is going to be going from 100 degrees Celsius cooling down to 20.8 degrees Celsius. That's going to work out to be a change in temperature of 79.2 degrees Celsius. Plugging this in here, plugging that in for solving for my energy, is going to leave me with a final amount of energy, 13,281.84 joules, or 13.28 kilojoules. All right, so now I have a sample of glass. Now this one's a two-part question. I need to first solve for the specific heat, then try to figure out what's going to happen if I change that temperature from 314 on up. So let's first solve for the specific heat. It's a 4-gram sample. I know that 32 joules are added to it, and my change in temperature is going to be 314 Kelvin minus 274, so it's a 40-degree Kelvin difference. Putting this into my equation here and solving now for specific heat, that's going to be Q divided by M times the delta T. So I'm going to put in my energy and my other values there. This is going to give me a specific heat for the sample of 0.2. Now I'm going to take that and I'm going to plug that in again with a new change in temperature to see what the amount of energy is going to be there. So, and then my specific heat is pulled from here, 0.2. The mass is going to be the same sample as before, 4 grams. And I know that 30 Kelvin is going to be the change in temperature. Solving that out is going to give me a difference in energy of 24 joules. Okay, another one here. I have 980 kilojoules. That's going to work out to be 980,000 joules. Plugging that in there. My specific heat for water is 4.18, and it's 6.2 liters of water. That's going to be 6,200 milliliters of water, and assuming we're at a normal temperature and pressure, which we roughly are, that's going to work out to be about 6,200 grams, because that's about the density of water. 1 gram per milliliter, 6.2 liters is going to work out to be 6.2 kilograms, is going to be about 6,200 grams. So there's my mass here, and my change in temperature is my unknown, what I'm solving for. So delta T is going to be the energy divided by specific heat times mass. That's 980,000 divided by these two numbers there, giving me a change in temperature of 37.81 degrees. Now, I started at 291 Kelvin. Final temperature of the water is going to be that plus 291, so 328.81 Kelvin.